Welcome to our Sheet Online Math class. This is the third problem for differentiation calculus. We have A, B, and C. All right. We are still learning how to differentiate basic functions. All right. So the first part here says find dy dx if y is equal to 1 over x plus 2 over x squared. All right, we are given y as 1 over x plus 2 over x squared. All right, so one of the easiest ways to differentiate this directly without using any of the techniques is to make sure that the function is in this format, ax to the power n. We want the function to be in this format. So in that case, x, the power of x, can either be positive or negative, but we don't want that x to be what? The denominator. Okay. So if we try to do that here, we can rewrite this like saying y is equal to 1 over x is the same as x raised to the power minus 1 plus we have 2 at the top. If this x squared moves to the top, we have x to the power minus 2. All right. So we've not differentiated, we've not performed any differentiation. Only that we just try to rewrite this function to be what? In this format. So having done that, we can now say y with respect to x. So we say dy dx. So the power multiplies the coefficients. Minus 1 times 1 is minus 1. Then we have the variable. So what next we say? We say the power minus 1. And we know that the power is minus 1. So if we say minus 1 again, so we have minus 2. The power is already minus 1. But according to differentiation of this nature, we must say what? Minus 1 again. So we get minus 2. So we come to this point. Now the variable is x, the power is minus 2, the coefficient is plus 2. So the power multiplies the coefficient. Minus 2 times plus 2 is minus 4. Minus 4. But we have the variable. What next we say? We say the power minus 1. But the power is already minus 2. So if we must say again minus 1, so it's like we have what? Minus 2 minus 1. That is minus 3. So this one gives minus 3. So now we can say, we can ignore 1 as a factor. 1 times x is x, 1 times v is v, 1 times a is a. So we ignore what? The 1. So we say minus x to the minus 2 minus 4x to the power of minus 2. But sometimes the examiner may want you to leave your answer what? In positive index, or the indices must be positive. So what do? We say minus. We move this x down again. So what will remain at the top? Minus 1. So minus 1. So when the x goes down, the sign changes to the positive sign. We have plus. So this is minus 4. When the x goes down, the sign changes to positive 3. So this is now in what? In positive powers, positive exponents. So the B part of the question says we are given function f of x. Function f of x says 4x squared minus 3x plus 4 divided by 2x squared. Unless if we want to differentiate this one using quotient rule. But if we want to maintain the general method of differentiation, well, we must see that we have the function written in this form, ax to the power n. We don't want to see x serving as the denominator. So to avoid this x being the denominator, what we do? We have to rewrite the function again. So every term of the denominator is to be divided by 2x squared. So we say 4x squared, this divided by 2x squared, minus 3x divided by 2x squared, plus 4 divided by 2x squared. We have not performed any differentiation. We just decide to what? To rewrite until we get this form, wherein the x is not serving as a denominator. So we say f of x is equal to 2 goes into 4 2 times. X squared takes away x squared. So the whole thing gives us 2 minus. This x takes away 1x. There will remain 1x down. So we have 3 divided by 2x plus 2 into 4, we have 2. So 2 over x squared. So we keep rewriting until we discourage the x from being a denominator. So we say 2 minus 3 over 2. This x has to go up with the sign changes. Here the power is positive, so the sign of the power changes to minus 1. Remember, here is a power of 1. So once the sign changes to minus, we have minus 1. So plus again 2, x goes up with the sign of the power changes. Here the power is positive. When it changes, it becomes minus 2. So we can see that we've satisfied that condition that we don't want to see x as a denominator. So now we can differentiate. This function is not labeled y. It is labeled f of x. So we are not finding dy dx. We are finding what? F prime of x. So see here, 1 means the first derivative. We are to differentiate once. So we say the first derivative of x. So this one is a constant. Differentiating a constant is 0. How do we know that this one is a constant? Because it does not contain x. Alright, so we come to this. X is the variable. The power is minus 1. The coefficient is minus 3 over 2. So what do we do? The power multiplies the coefficient. The power multiplies the coefficient, that is minus 3 over 2. The power of x is minus 1. The coefficient of x is minus 3 over 2. So multiplying them will give us minus times minus is plus. 1 times 3 over 2. 3 over 2. So we write our x. What next do we do to the power? We must say minus 1. It is minus 1 already, but the process demands to say what? Minus 1 again. So this minus 1, minus 1 again, we have minus 2. So again, the variable is x, the power is minus 2, the coefficient is plus 2. So minus 2 times plus 2 is minus 4. We have the variable, then we must say minus 1 again. Minus 2 minus 1 is minus 3. So this is 3 over 2 x to the power of minus 2 minus 4 x to the power of minus 3. This is the result we get. Unless if the examiner requires the answer to be what? With positive index, positive indices. So in that case we say 3, the x goes down, there is 2 down there. So when the x goes down, the sign of the power changes to the positive sign. So we say this. Minus 4, when x goes down, the sign of the power changes. X to the power 3. So this is the first derivative of x. So we have a similar one here. We have similar one here. f of x is 1 minus 3x plus x squared over x to the power of 3. We want to differentiate this once. So first of all, let us rewrite. 1 divided by x cubed minus 3x divided by x cubed plus x squared divided by x cubed. So f of x is what? 1 over x cubed minus 3 over. This x takes away 1x here. There will remain x squared plus x squared means we have 2 pairs of x. X cubed means we have 3 pairs of x. So 2 pairs of x takes away 2 pairs of x. So at the top there will remain 1. At the bottom there will remain just x. Because 2 pairs of x at the top take away what? 2 pairs of x at the bottom. So, but our target is to rewrite this until we discourage the denominator from having x. So we keep going. F of x is equal to, this one goes to the top. We say x2 minus 3. The sign changes because we move the variable from the denominator to the numerator. Minus 3. We move this to the numerator. So the sign changes to minus. We move this to the numerator. The sign changes to minus. We don't see this one again because this one is here. This 3 is this one. This one is this one here. So now, differentiating this, minus 3 times 1, minus 3. Minus 3 minus 1, minus 4. Minus 2 times minus 3, plus 6. Minus 2 minus 1, minus 3. Minus 1 times plus 1, minus 1. Minus 1 minus 1, minus 2. So this is correct, it is fine, it is good. But if the examiner asks you to leave your indices to be positive, you have to do the right thing. So we assume this is the result we have been finding. Thank you for watching. Don't forget to like and share the video. And don't forget to subscribe for the YouTube channel. Bye bye.